useMemo, it is one of the important concept when we talk about memory utilization or performance basically. So let's see what React has to say about useMemo. Okay, these are three major concepts when we talk about memorization. Called useMemo. So here in this example, we are going to create three counters. Hey guys, welcome back to our channel KnowledgeKeen, and this is your friend Wasim, and today we are going to see another example of useMemo. Okay, we are going through a whole flow now. Okay, we have finished all the basic hooks, you can say, and now we are going to our uncommon or intermediate hooks. So out of which one of them is useMemo. Okay. useMemo, it is one of the important concept when we talk about memory utilization or performance basically. So if any time in your life, if you're thinking that how to improve your performance of your application, then we should go ahead and use useMemo. Okay, how it is important, why it is important, and when should we use it and when should we avoid using it. Yes, we are also going to talk about how when we are going to avoid using useMemo. Okay. So without wasting any time, let's begin quickly with our examples as we always do. So let's see what React has to say about useMemo. Okay, if you see on the screen, it returns a memoized value. Okay, basically now a memoized value. If you want, we can just quickly control click. We go to this. It's memoization. In computing, memoization is optimizing technique using primarily to speed up computer programming and so on. So we don't want to go into this. Okay, we want to see what exactly it does. So there are three things. Okay, our previous example was useEffect. So there are three things. The first one is useMemo. So this is going to return returns a memoized value. Okay, React.memo. Okay, so useMemo is a function. This is also a function. This returns a memoized component. Okay, this returns a memoized value. This returns a memoized component. And the third thing we have is use callback. This is also we are going to see, not in this video, in the upcoming videos. Both of them we are going to see in the upcoming videos. Here in this video, we are just specifically targeting about useMemo. You know that we only specifically target only one concept and we drill through it. So this returns a memoized callback, or to make it more simple, it's a function. Okay, so it returns a memoized function, you can say, or memoized callback. So these three things, all these three things are important. Okay, very important. These are three major concepts when we talk about memoization. useMemo, we are going to see. React.memo, we are going to see in the next video. Callback in our later videos. Yes, so these three concepts are important. You have to remember it using, when we talk about useMemo, you should always remember that it basically returns a memoized value. So when we talk about React.memo, it returns a memoized component. So the component is important. In useMemo, value is important, and in use callback, the word itself says callback is important. So let's see. We are going to see examples or multiple examples on all these concepts. Okay, but for this video, let's talk about our favorite, useMemo. useMemo hook. .js. Basically, I'm going to create two examples. So this is going to be our example one. Why two examples? We'll see. So let's create a component and then we'll basically talk about it. useMemo hook, example one. It's a simple component. We have done this 1,000 times. useMemo, let me just write it in H4. hook. I'll simply export default useMemo hook. Our app useMemo hook example 1. We do not this, and let's quickly go back. See, simple, a component. Okay. Now let me quickly jump to the example that we're going to see. So here in this example, we are going to create 3 counters. Okay, 3 counters, that means 3 use states. We have seen use state. If you're not seeing a use state example, I'll be just pushing a link somewhere here or here. Just you can click on the I button and you can see that video. But for now, we are going to create 3 counters, that means 3 use states and 3 buttons. So if I click on button 1, basically I'm going to increase the counter 1. If I click on button 2, it is going to increase the counter 2, and if I click the button 3, it is going to increase the counter 3. Straightforward, very simple. Okay, a simple example. But whenever we are talking about memoization, we have discussed this before. Whenever we click on any button, basically we are updating any state, our component re-renders. Memoization works on this principle of re-rendering. If you're anytime if you're thinking about a re-renderation process, then you should always know that how my component is going to re-render and when my component is going to re-render. To check if your component is re-rendering, I told you in the previous example, you can use useEffect. But let's skip all of them and we'll see here that 3 counters, simple. If I just click on the count 1 button, let's say that I have added a count 1 button just to segregate this, it is going to simply re-render it. So it disappears and re-renders it, right? So all of my count 1, count 2, count 3 will be re-rendered. Count 1 will just throw the updated value. The same goes with my click on count 2. If I'm clicking on counter 2nd, it is going to re-render. The same goes with my counter 3. If I click on the count 3 button, it is going to again re-render. Pretty simple. Okay, till now we have all studied this. Okay, now let's think that I have added a hefty function. Okay, I have added a heavy function when I'm just checking whether my count 1 is an odd number or an even number. Pretty straightforward. But what I do, I add a simple for loop or a while loop which runs for like a couple of lakh times, okay, or a million times. When we do this, okay, we'll just add, I'll run this example and I'll show you what exactly I'm talking about. But just think of it that this check order even is a very hefty function and it takes a couple of milliseconds or seconds to just get executed. Okay, simple. But this order even checking, we are just going to do it on count 1. We are not going to do the same odd even checking on count 2. We are not going to do this on count 3 as well. See what happens. If I click on count 1 button, it is going to again check for your order even if count 1 is order even. It will take some time and it will basically re-render. Yes, because it is a hefty function, so it takes some time. I have just tried to simulate it. The same happens if I do with count 2. Basically, it does not have anything to do with my checking of count 2 whether it is odd or even, because we are only checking for count 1. But see, if I click, it takes some time again. Oops, did I do something wrong? Nope. Here, if I click on count 3, again it takes some time to re-render. Why? Okay, now there are a lot of questions that we are only checking count 1, but why it is taking time for count 2 and count 3 to get updated. Okay, to resolve this, we use useMemo. Okay, interesting. So if I do the same thing, just added a use function, useMemo, we are going to see how we are going to use it, where we are going to use it. But for now, just conceptually, if I click on count 1, again, because it is a hefty function, it has some checking to do, it takes a bit of time, right? But now, if I do the same thing with count 2, it will quickly re-render. If I do with count 3, it will again, so it in a flick of a second, it will just re-render. So this is nothing but using useMemo. So I tried to simulate whenever it is needed, okay, wherever it is required for hefty functions to be executed, it is definitely going to take time. But where it feels that yes, this function is like it does not have to do anything with my count 2 or count 3, so it will just skip that. It will just run. To think it in this way, think it like that. Whichever function is hefty and wherever we are using a useMemo, okay, it will just remove it from the re-renderation process. Okay, it will just create it, memoize it, caches it. Memoization is something related to your caching, so it caches that function, so it does not have to re-render again and again and again. So let's keep it in our mind that whenever we use useMemo, it will cache that function into the memory. It will just keep it aside, and wherever it is required, it will rerun it again. But if it is not required, it will run it from the cached function. Let's see how. We'll quickly jump back to our example. So as I said, we'll create quickly const useState. Oops. Count 1. Let's take the same example. useState, I'll import it. The initial value would be 0. Count again 2. And count 3. We have 3 useStates. I'll just quickly say count 1 and its value count 1. The same goes with my 2. The same goes with my 3. And I'll just have on click on click handle click 1. Let's add 3 different callbacks. So increase count 1. I'll add a click 2. I'll add a click 3. I know you might feel that this is a bad way, but for now we are not thinking about a good or a bad way. We are just trying to add simple functions. So what we are going to do here, we are just simply set count plus 1. Can I do this? I think so. Oops, count 1 plus 1. The same goes with my 2, 3, 2 and 3. Simple. If I click on increase count 2 and count 3, we'll just add some BRs. Come on, and a BR. Yep, if I click on count 1 will increase. If I click on count 2 will increase. If I click on count 3 will increase. See, simple, right? It's pretty easy how we are going to check whether count 1, count 2 and count 3 are increasing. You can just do it like 100 times and it will still work. This is simple. We have seen this till date. Okay, in all our previous example, we have done this like 10 times now. Let's add something more. So where we are printing count 1, what we will quickly do is check odd, even. Okay, we'll call a function. If it is true, return it is like even. If it is false, let's quickly say that it is odd. Right? Ternary operators, we have seen this in JavaScript. If you have not seen my JavaScript videos, please go quickly and see that. I'll const check odd even, again another function. What we will do, we'll just quickly return. Let's see first if we come into this function in check odd even. Here, if count 1 modulus 2 is equal to 0, there is no 4 equals, return true, else return false. I hope this works. See, refresh. 0 is even, 1 is odd, even odd, even odd. This works. Yep. And if we go here, the check odd even, it has an around 24 times, but that's fine. We don't want this. Basically our check odd even function always works. We are calling it immediately. We'll remove this console as well for now. We don't want console. Refresh. So for now, what have we learned till now? Okay, whenever, oops, what did we learn till now? Simple. We wrote simple functions. We wrote handle events. Okay, clicks, increase in counters. We will add some hefty function into this odd and even. We'll do nothing. We'll simply let I equal to 0, and let's say that while I is less than million times 1 2 3 4 5 6 7 8 9 10, some huge number times. Okay, just do I plus plus, nothing. We are simply taking I. It starts from 0, it goes till I 1 10 times 0, and it will just keep on increasing. So this is going to be a heavy function, right? So this is going to be our heavy function, but it is not affecting our count 1 in any way. So we remember JavaScript, right? It is an interface, so it will just execute line by line execution. So it will just do line by line execution. It will just finish let and while loops first, okay, and then it will go to our return. That means our execution would be a bit slower. Save. We'll quickly refresh, and I will click on count 1. Yes, it takes some time. Did you see? I'll just do it one more time. I'll click it, and it takes some time. Click it, and it takes some time. So basically, this is a very slow process for count 1, because it is continuously checking for count 1. But what will happen if I click on count 2? See, it is also slow. I click it, it increases. I click it, it is slow. Count 3, I click it, it's slow. I'll click it, it's slow. So basically, this is now a slower process, okay, because of that heftier function. So why does this happen? Why it is slow? Because React keeps on re-rendering this check odd even function with each time whenever my component gets reloaded. So basically, when my count 1 is changed, okay, my component is reloaded, count 2 is changed, component is reloaded. So every time this happens, my check odd even function gets called again, and as it is a huge function, as it is a heavy function, it makes my application a bit slower, irrespective if it is checking for any of the counters. How do we solve this? Now useEffect comes to our useEffect becomes our useMemo becomes our savior. Why am I going to useEffect? Okay, so how does useEffect help here? So useEffect, as I said, it will basically cache our function. If from all this function, if count 1 is never changed, we don't want it to be executed. We want the function as it is. So use it from the cache. Please don't rerun it again. We are just going to say that. So how do we use useMemo? We'll see a simple example. We have learned useEffect previously, and use callback, useMemo. The way of writing is same. So how do we do that? Basically, see, useMemo, round bracket, the first parameter would be my anonymous function, okay, and the second parameter would be the dependency list, okay. So it will basically check what are the dependencies my useMemo is going to go through. The first would be my anonymous function, or basically the function that you want to memoize. So here my memoization function would be my check odd even, right? So this anonymous function I want to memoize, and then my parent dependent would be count 1. So this useMemo should be run only and only if my count 1 changes. So how do we write that? We'll first import it from React. You don't need to import lines, you just need useMemo here. I don't know why I did that. And now let's quickly, the first parameter, okay, control X and useMemo. The first parameter is my function. Whatever I cut, I paste it here, remove the semicolon because I don't want my line to be ended there, and the second parameter is my dependent list. So keep an eye on this count1 and rerun this useMemo only and only when my count1 change. So that's what we are going to see. Save, refresh, something broke, check odd-even is not a function. Okay, now it is returning a memoized value. It's not a function. Sorry, my bad. It ran again. Refresh, just for my satisfaction. So now if I click on count1, it takes time. Again, I'll just count 2, it takes time. Count 3, it takes time. But if I do, I'll be not so fast because it will just, it's quick. It is fast, right? So now what basically my whole React is doing, it is memoizing that function. So it is keeping that function aside just for saving that memory, saving that, caching that function. It helps to improvise my performance. This was the first example how you can improvise the performance, how useMemo works. I hope you are able to understand this, how useMemo is working right now, and how we are trying to make it more better. The second function is also a small quick example. Let's quickly jump to our next example. We'll create another component. Let me quickly do that. useMemo hook example2.js const. Okay, my function, I'll be pretty fast. H4 use